Hi, welcome to the channel. Here I post challenging math problem video daily. If you like this video, then give it a thumbs up and subscribe to the channel. So without further delay, let's start. Today we have a problem which says let Cn be an infinite sequence of a circles lying in the positive xy plane with strictly decreasing radii. The following condition: each circle touches x and y axis. Further, for all n greater than 1, circle Cn plus 1 touches the circle Cn externally. So based on the above information, choose the correct option of the following questions. So this is basically a STEM problem. So based on this information, three questions are given. So the first question is the sum of area of all such circles when radii of the first circle C1 is 10 centimeter. Four options are given. Similarly, second question is the radius of the second of any circle CM is given by Rm equal to alpha by beta to the power gamma R1, where R1 is the radii of first circle C1. For m equal to 9, the value of this 2 alpha minus 2 beta plus gamma is. And the last question is the common tangent other than the axes between the circle C4 and C5 is given by x plus y equal to root 2 R1 k, where R1 is the radius of the first circle, and then k is four options are given. So let's draw the figure first. So this is the figure. So let me explain. Say this is the x-axis and y-axis. Okay. Now this circle C1 with a radius R1, it touches the axes x and y. Similarly, the second circle C2 touches both the axes as well as the circle C1, and the circle similarly the circle C3 you can see. I'm just it touches the axis and C2 and so on. Okay, so what we can do? Let's start the solution. Let's say this has the radius of R1, so this touches both the axes, so the center should be R1, and similarly for the circle C2, let the radius be R2. So as it touches the axis x1 x and y, so its center be R2 and so on. So let's do one thing. We know this circle touches each other, so this is the center R2, and this is R1. Okay, now this circle is the radius is R2 and this circle is R1. So this is the given condition and so on. Okay, so now as we know, this is C2 and this is C1. Distance between center equal to distance between their radii. Okay, so what we can write is, say, R1 minus R2 square plus R1 minus R2 square under root equal to R1 plus R2. So this is 2 R1 minus R2 square equal to R1 plus R2. Okay, so if I take this root out, so we can write this as R1 minus R2 equal to R1 plus R2. Okay, so what we can do is take just a minute, this is R1 minus R2. Okay, I take that side, so R1 minus R2 equal to R1 plus R2 equal to 1 by root 2. So solving this, we get using componendo dividendo, applying componendo and dividendo. So what we have here is, this is 2 by R1 divided by 2 by R2 and this is 1, this is minus 2m. So 1 plus root 2 divided by 1 minus root 2. So these two R1 will cancel out. So R2 can be written as root 2 minus 1 divided by root 2 plus 1 R1. Okay. Now we can, if we plot similarly for the circle C2 and C3, okay, similar expression will get. So R3 can be written as root 2 minus 1 divided by root 2 plus 1 of R2. Now if we substitute in terms of R1, so we get this as R1. Okay. Similarly for C3 and C4, R4 equal to root 2 minus 1 divided by root 2 plus 1 R3, and if we write in terms of R1, we get this. So you can clearly see this is basically forming a GP whose first term is R1, second term is R1's, just a minute, second term is this factor into R1, third term is this square R1, okay, and so on, okay, and it is going till infinitely. So we can write R of any radius n as root 2 minus 1 divided by root 2 plus 1 to the power n minus 1 r. Okay, so this is the expression of any circle with respect to the first circle. Okay, now let's solve this problem. First problem is sum of area of all the circles. So as we know, area equal to, for the first problem, area equal to pi r1 square plus pi r2 square plus pi r3 square up to infinite. Okay, so pi r1 square we take common, so we can write this as, and r2 square in terms of r1 we can write this as root 2 plus 1 whole square root 2 minus 1 by root 2 plus 1 whole to the power 4 plus up to infinite. So if we apply the equation of s of infinite, so we can write pi r1 square, this is one common ratio is this root 2 minus 1 divided by root 2 plus 1 whole square. So if we simply solve this, so pi r1 square into this root 2 plus 1 whole square will get in the numerator, and this is root 2 plus 1 whole square minus root 2. Okay, let me write once again. So this is 4ab. Okay, so pi r1 square into root 2 plus 1 means this is 3 plus 2 root 2, and this is 4ab, so 4 root 2. Now r1 is given as 10 centimeter. Okay, so r1 is 10 centimeter, it is given. So if we put r1 as 10, it is given r1 equal to 10. So this is 10 square means 100. This is 3 plus 2 root 2, and 3 minus, if we, the options are given this as 3 minus 2 root 2. Okay. So we rationalize the numerator actually. So this is 4 root 2. So 4 root 2 means 25, and this is 25 pi, and this is 3 square minus 8 means 1, and this is root 2 means 3 root 2 minus 4. So this is the answer to the first question. So check with the option. Option C is correct. Okay. Now second is, if the radius of any circle is given in terms of Rm as alpha by beta to the power gamma into R1. So we have already found out the relation. So let me write the relation once again. So R of M as root 2 minus 1 divided by root 2 plus 1 divided by m minus 1 into R1, and in our problem it is given as alpha by beta to the power gamma R1. So if we compare this, so we get alpha as root 2 minus 1, beta as root 2 plus 1, and gamma as m minus 1. Okay. Now this m is given as 9, and so if m is given as 9, so gamma equal to 8, as m equal to 9 it is given. So gamma we have found as 8, and we have to find the value of 2 alpha minus 2 beta plus gamma. Okay. Yes. So just substitute this value. So we take 2 common. So alpha minus beta. So alpha minus beta means this root 2 will get cancelled, and minus 1 into minus 1 means minus 2 plus 8. So this is 4. Okay. So the option to the second question is 4. So option B is correct. The third question is, the common tangent other than the axes between the circle C4 and C5 is given by x plus y equal to root 2 R1k. So okay, let me draw one figure. So this is the circle, okay, and another circle is, say, this is another circle. Okay. So at this point, if we draw the tangent, okay, so let this be the tangent. So this is given as x plus y equal to root 2 R1k. Okay. And this is circle C4, I think, and C5. Yes, C4 and C5. Okay. Let me write, this is C4 and this is C5. So okay, what we can do is, this is problem number 3. So for this C4 and C5, this is C5 and this is C4. So the center is, we have to find out this P point, okay, at the point, this point of contact. So C5 is R5, and this C4 is R4. Okay. Now this is the P point, let it be x and y, and this C5P is, this is R5 and this is R4. Now using section formula, we can write as R4 into R5 plus R4, and similarly y is also same. Okay. So we can write this P point as, so this is P point x comma y. So this coordinate is 4 plus R5. So this is 2R4 R5 divided by R4 R5 divided by R4 plus R5. Now this is the point of contact. Okay. So this point of contact will satisfy this equation. So if we substitute the value of x and y, we get this as root 2 R1k equal to 2 plus 2 means 4, because everything is same. Now we have to just write the value of R4 and R5 in terms of R1. So our R4 and R5 is root 2 minus 1 divided by root 2 plus 1 minus 1 divided by root 2 plus 1 to the power 4 of r1. So okay, let me write this root 2 plus 1 by root 2 minus 1 as factor as a, so it will easily we can calculate, otherwise we have to write it again and again. So uh, okay, so k is say root 2 r1 k. Now this 2 sorry 4, and this is r4. R4 means this one and this one, so a to the power 7. Okay, and this is r1 square and r4 plus r5, to taking a cube common, so we can write this as 8. Okay, now this r1 square get cancelled everything, and this 8 to the power 4, so k can be written as 8 to the power 4 and a plus 1, and this is 4 by root 2 means this is 2 root 2. Okay, now this a4 means just substitute these values. Okay, so a4 means this root 2 minus 1 to the power 4 divided by root 2 plus 1 to the power 4 into a plus 1, so a divided by root 2 plus 1 and root 2 plus 1 will go in the numerator, so this will get cancelled, this two things will get cancelled, and 2 root 2 will get cancelled from here. So we just write our final equation of k as this is cube and this is 4. Okay, so this is the value of k. So let me check the options. So numerator is 4 and denominator is 3, and this, okay, so this is the correct option, option C. Okay, so this is a kind of STEM question. Okay, so this is all for today. See you tomorrow.